the default. So what can go wrong? Probably one of the biggest areas of complaint with partitions is you get called back and people say, I can hear people next door. And that could be because of the background noise level being too low, but it can also be through something known as flanking sound. And that's where sound finds its way around the partitioning which is blocking it. So let's get my pointer again, because I can point these out to you. This is a typical one up here. It's a blind box on the outside of a window. And quite often the partitioning is built through to that point, and that infill is of a lower performance than the partition. And the sound will go through there. Or you might have a situation where the partition has been built to the underside of a suspended ceiling, and the sound will go across the top. And I'm going to show you how to deal with that particular issue later. This is another sound path where sound will go in through ducting and come out the other side. Gaps around doors are another one. Gaps under partitions, partial penetrations through the partition. Any grills, of course, sound will go through that. This is a real example, and something that took us a while to find out on a project in Canary Wharf, where the cladding had been put on the columns and it was just 9.5mm board, nothing in there at all. Partition was fine, but the sound was actually coming through those columns. We remedied it by taking it off, putting an infill, doubling up with the board on the outside for the next part of the refurbishment. You can also actually get some sound being transmitted through the facade itself. And a lot of designers have realized that and are working to other ways now of dealing with that. But these are all sound transmission paths through flanking. One of the ways you can avoid it in a modern office is by taking the partitioning through the front of the glass and offsetting the doors, so you haven't got the doors going side by side. And that will help as well in terms of sound going from office to office. So let's look now at partition and those flanking paths in a little bit more detail. So here's a partition been built to the underside of a suspended ceiling. Some of the sound will hit it and be reflected back, some of it will be transmitted through, and then the sound, like water, will look for other ways to get through. Gaps under the partitions, gaps under the raised floor, gaps above the ceiling, and through any ducting as well. But you can mitigate against these by a number of measures. You can put insulation below the partition, you can put insulation above the partition as well. And that's really quite a good way of building your partition so that you can move it around later. But you also then need to do something about the ductwork, and you can put sound attenuators within the ductwork to reduce that. Really, if all else fails, you can also build your partitioning either from floor to slab or from slab to slab. But bear in mind at that point there, you'll also need to consider putting a deflection head in as well. I put this slide in because we forget about sound transmission down pipes and tubes, and the Navy have been using it for years to communicate with the engine room in a noisy environment from a bridge all the way back to the engine room. So that's all that ducting is. It's exactly the same thing, and we've got miles of it above suspended ceilings. So this is one of the ways that you can insulate against sound transmission above a suspended ceiling using a proprietary, and these products are sold as fire blankets more than anything else, but they are tested, and you can install them in single layers and you can install them in double layers. Where you do install them, obviously make sure that you completely cover the head of the partitioning. Any gaps, the sound will go through. And here's a little hint for you as well. If you install these along the bisecting runs and just in a T-shape a little bit across the front, it will actually allow a little bit of the sound from the open office to leach into the individual offices. And what that will do is people will come into the office, they'll be able to close the door and note that there's a difference between the two, but some of that background noise will help insulate against the sound going from side to side. It will cover it, it will mask it. Ultimately you can always add in more later, but you can over-insulate some rooms, and it's a little hint that I've used to great effect in the past. Remember, below the floor, this is a fire barrier, but a sound barrier would work in exactly the same way. Make it airtight and you're stopping the sound going from one side to another. But the other thing we tend to do with partitions is put holes in them in one form or another. One hole is called a door, and another partial penetration is sockets, cleaner sockets. If you are putting a cleaner socket into a wall and you need sound performance, at the very least offset them by a panel at least so that the sound can't get through. But you can also use proprietary products like this that go into the back box, glued back, and then they're fixed in place through these wooden sections here, and that will help reduce the sound transferring from one room to another. Doors are a weak point. They're never the same performance as a partition, and they've got gaps all the way around them. So one of the ways to deal with that is to use, again, a proprietary product here. In this case, a smoke seal, cold smoke seal. And the way these work is they're sprung loaded, and when the door opens, there's two lugs on either side that drop away, and the springs go up and the door goes through. You don't have to use a threshold, they'll work without a threshold. And when the door actually closes, they drop down and they just seal that gap under the door. Very, very effective. But you do need to calculate the effect of a door on the performance of a partition as well. And there are some guidance notes within the document which will help you do that. There's also an application which is available now on iTunes, an acoustic app that will help you calculate the effect of different products on a wall as well. I'll talk to you about that a little bit later when we come to put all of the products together. So open areas are one of the areas where we know that there is an issue of sound transference in an open space, perhaps between one department and another. Well, we know that sound will naturally dissipate with distance, and we know that you can use freestanding screens to help absorb some of that sound as well. The other thing that we would recommend is that you also look at putting some additional absorbers in the area above where the screen is, and that will help reduce the sound that would bounce and come back down there. So you've got a couple of areas which will reduce it. People generally will be sitting down below a screen, and here you really need to have screens at about 1800 high between departments, so that you have a degree of a reduction in sound from one space to another. And what you're looking to do is to reduce distraction from one department to another. So what happens when you mix products together? Here's an example where you've got, let's say, a partition at 30 dB, a floor and a ceiling at 30 dB, and it's a bit of the Brucey this, is it higher, is it lower? The answer here is that if all three products performed as they did in the laboratory, the overall effect would be lower, in this case by about 3 dB, because in essence what's happening is that this partition here is acting as a little sounding board, so the sound is doing that, the ceiling is doing the same, and the floor is doing the same. So even if they performed the best that they could, you're never going to achieve exactly what you get into a laboratory. There will be a reduction there of the two. And this application will help you calculate the effect of elements together, doors and glazing in a partition, and it does it by looking at the size of the room, the sort of reverberation that you get within the space as well, and will help you design the product to suit the application. So how do we describe different ways of transmission? One of them is the speech transmission index, STI. And the higher the number, the better it is for communication. Conversely, the lower the number is, the better for privacy. The only way to actually calculate an STI is with software on a computer. It's the sort of thing that an acoustician would do as part of the design process. The other thing that is often used is SNR, which is the speech-to-noise ratio. So if you are in a railway station, the speech-to-noise ratio could be quite high, so it can be quite difficult to hear what an announcer is saying. And in order for speech to be understood, the speech-to-noise ratio needs to be about 10 to 15 dB above the background noise. Conversely, if you do it the other way, then you're back to the privacy factor again. But about 10 to 15 dB above background noise. So it's also important to try and look at the rooms themselves and see where the sound is actually going to end up. So if you've got sound starting in one corner of a room, which could be quite loud, where's it going to go? Now bear in mind, every time it bounces, it'll lose a little bit of energy, so it'll bounce around in there. But eventually some of that's going to come out. And this is quite often used in schools. Acousticians are well versed with using this software, and again you can get them to look particularly at some ray tracing as part of the design process. Within the guidance, this paper was first presented at Euronoise by the principal author of our guide, Andrew Parkin. And he looks at two scenarios, working within a cluster and between work groups. And he's given some targets for the speech transmission index and also about the amount of absorption which is required per square meter over that space. Really quite specific, and one of the key points of our acoustic guide. If you're working with an acoustician, if you showed them this information, they would certainly be able to help you design the space to meet the requirement in an open plan office. If any of you are working in schools, and possibly in hospitals as well, you'll know that there's good guidance out there. In terms of schools, it's Building Bulletin 93. And schools have at last woken up to the fact that if the room is too reverberant, it will become too noisy, and the students will find it very difficult to be able to hear the lessons. But if it's too dead, they won't be able to hear it at all. So there's got to be a balance there. And this is lifted straight from BB93, it's table 15. And then you've got a list of scenarios, different types of rooms, seminar rooms, atria, lecture rooms, and what you should be aiming for in terms of reverberation within that space, from about a second down to about 0.8 of a second. And you can take that same type of guidance into open plan offices and conference rooms within the commercial sector.